Well, if your truck is like this one and you have to rely on the old 255, 2 windows down at 55 miles an hour, this show's for you. Today on Tech Garage, we're talking about air conditioning, power windows, and power door locks. Welcome to Tech Garage, presented by Advance Auto Parts. Today it's all about the air conditioning system. Whether you have a TXV or an orifice tube system, we got you covered. And if you don't have air conditioning, we're going to talk about power windows and door locks a little later. Now, cars use air conditioning system and a principle of heat transfer. Well, what does that mean? The air conditioning takes the heat out of the car. Thus, you're feeling a little bit colder. So we need to talk about a little physics class first. And I want to start out with heat transfer. Well, I got a good cup of coffee here, a good tasting cup of coffee, but that's not the point. The point is it's hot. It's hot coffee. So what's happening here is the heat is transferring from the glass to my hand. If I hold it here, I don't feel it. But if I hold it here, it's going to transfer it to my hand. And it's continued to transfer it until there's no more heat difference. Heat moves from hot to a place containing less heat. And it does it 3 ways: conduction, convection, and radiation. And I can demonstrate conduction for you. It's real simple. And I hold this rod there. Well, you know it. I'm going to feel that. Once I start to feel that heat, that's conduction. Convection is actually wind blowing through, the fan. We're going to see the fan blow through and the blower motor blow through, and it's going to transfer that heat. And the last is radiation. We're all familiar with that. You go out in the sun, you feel it, it's hot, that's radiation. Now, to understand it completely, we have to understand the AC cycle. And our friends from Console Lab over in Canada sent this board over, and this is phenomenal. You're only going to see something like this on Tech Garage. This is going to show you the complete AC cycle from the start to the end. These components are actual components. There's blower motors on the back, a compressor on the back. This is actually an evaporator, and that's actually a condenser. So what I want to do is I want to go through the AC cycle with you. It all starts right here at the compressor. Now our compressor is going to be belt driven, and it's going to go ahead and compress the Freon. Well, it compresses the Freon, a gas, a refrigerant. The gas comes in. When it compresses it, it also superheats it. It gets it really, really hot. And this is cool because you can actually see it. What's happening here is I come up with a high pressure gas. There's a gas flowing through here right now. And then what happens, it goes to this condenser on the front of the car. Well, think about your bathroom mirror. When you're taking a shower, you come out and that steam starts coming down there. That's what's happening here. But check this out. You go through here and you can see it actually starts to condense. It's about halfway condensed there. And then when we get to the bottom, it's actually a liquid. So we come out a liquid, but it's still a high pressure liquid. Now, as it comes out a liquid here, what's going to go on here? This is a high pressure liquid all the way up here to what's called an orifice tube. This is an orifice tube system. A little later, we'll look at a TXV. Now, this orifice tube sits right here, and this is a fixed restriction. So what's happening at this portion of the system is it's going from a liquid to high pressure to a liquid low pressure. It's not changing states, but it's changing pressure. Remember the high side you may have heard of, or a low side on a car? Well, here we go. Now we start the low side of the system. The low side of the system comes around here, and when it comes around here, it's going down into the evaporator. Now the evaporator is located inside the car, or some case duct system maybe up under your hood. But what that does is the blower motor inside the car spins across, and it's putting the air across that evaporator. Well, remember the heat transfer. Once again, it's 80 degrees in your car, 90 degrees in the car. And what's happening here is when the Freon changed pressures, it got very, very cold. This is the coldest part of the system. So the refrigerant or Freon's coming down here cold. And when it comes down cold, it goes into that evaporator. And when it goes into the evaporator, the heat's going to jump from the car onto the Freon. And then it's going to take a ride. So what happens here, here's our liquid. And this is so cool because it goes up, it starts to evaporate. And when it evaporates, you can see I'm losing it here, and then I have nothing more than a gas, because to get back to the compressor, we have to have a gas. It can't compress liquid. And we come up here through here, and as we come up through here, it's going to come over to what's called an accumulator. Now, an accumulator on this system It's nothing more than a storage device to store a little bit of the refrigerant. If it's liquid and it got through the evaporator, it has to turn to a gas before it gets to the compressor. And there's a desiccant bag in here. Now this desiccant bag dries the Freon because you don't want any moisture in your AC system. That's why later when we vacuum a system down, you'll know why we're doing it, because we don't want moisture. Moisture is going to corrode and get into the system. Then what happens from the accumulator, it's going to come out the accumulator and it's going to come down to the compressor, and it's going to start that process all over again. Now that's a good look at an orifice tube system. We need to switch gears and look at a TXV system, and we'll do that as soon as we come back with more Tech Garage presented by Advance Auto Parts.
This edition of Tech Garage is being brought to you by Advance Auto Parts. Let's get you back to the garage. AC Pro, do-it-yourself AC recharge for cars and trucks. ARP, the world leader in fastener technology. And by Locar, quality plain and simple.
Welcome back to Tech Garage. Well, we understand all about an orifice tube system. Let's look at a TXV, thermostatic expansion valve system. And you know, we have it right here on MotoLogic. Professional technicians use this MotoLogic system and we get a peek at it. You can see right at the top of the page, it all starts at the compressor. Nothing different, except there's an S and a D here, suction and discharge. We're gonna start out the discharge. That's the high pressure line. I come over here to the left side of the page, you can see the condensers right there. Well, it goes through the condenser, and then there's a little change. There's a receiver dryer on the left side of the page instead of an accumulator. That's in a liquid line. On the orifice tube, remember the accumulator was in the line going to the actual evaporator. Then I come down here, and I go through the TXV, the thermostatic expansion valve. We'll take a look inside of one of them in a minute, but that's what regulates the Freon, just like the orifice tube did, into the evaporator, right there on the bottom of the page. And then it comes all the way back up to the top, and it starts at the compressor again. Now, I have an actual system right here that we can see. This one's out of a Nissan Frontier, this one's out of a Cavalier. They all run the same. It's the same principles. And it starts right here at the compressor. The compressor comes out, and it'll go right to the front of the car, and on the front of the car, in front of the radiator, you have what's called a condenser. Here's the fan blower motor, transferring that heat. Remember, it's going in hot, outside air's cold, boom, transferring the heat, taking it from inside the car out. Then what we do is we come out to that receiver dryer in the liquid line. Accumulator in the gas line, this one's in the liquid line. As we come out that, it does the same job, okay? It still cools, it still cleans, and stores a little bit of refrigerant. It comes through here, and then it goes into what's called a TXV, thermostatic expansion valve. And I got one right here cut away, so you can see what happens. The orifice tube was fixed. This one, not so much. The line right here goes on the outlet of the evaporator, and it meters, it throttles. There's a diaphragm in here, and depending on the temperature, it allows the Freon to come out. Now, if this falls off, it's out in the outside case, it's gonna sense that it's hot, it's gonna let a lot of Freon in there, so make sure that's secure there so you get the right temperature readings. Then it meters it, it allows it to come into the evaporator. Here's the blower motor inside the car, that's transferring the heat from there to the Freon, and it's gonna take a ride to the compressor and start the cycle all over again. So now that you understand TXVs, let's go to Brian with the email question of the week.
John, I've got an email question here from one of our viewers, Trent, down in Tulsa, Oklahoma. He recently replaced his air conditioning compressor. Now the system blows ice cold air, but only right at startup. What's your advice for Trent?
Brian, this question is perfect because this is why we need to understand that AC cycle and we need to understand the AC components. But more importantly, Trent, you're gonna have to hook up some gauges and find out what's going on with your system. Now you can go down to the auto parts store and pick you up a set of gauges. These gauges are gonna tell you exactly what's going on with the system, and they're real easy to use. I already hooked up the low side in the back of the truck here, and if I just take this off, I'm gonna go ahead and hook up the high side. These are quick disconnect fittings. Come down here and pop it up, and then screw it down and open up the gauge. Now those gauge readings is gonna tell us exactly what's going on. But in Trent's case, you might have some moisture in the system. What's happening with that moisture is as it's running, it's freezing up and it's blocking that refrigerant flow. When it blocks that refrigerant flow, the key is, shuts his car off, and then all of a sudden it starts blowing good again. Well, that water probably melts, and then what happens, the Freon works great till it refreezes again, or the evaporator's freezing. But if you go down to a professional shop, they can recover the Freon. You can come back and take this vacuum pump and hook it up, and then what you want to do is you want to evacuate the system. You want to suck it down into a vacuum. That'll get all the moisture out. I like a minimum of 45 minutes or more. That's going to make sure all the moisture's out of the system. Now I have a few gauge readings for you, and this is really cool because you can take the gauges out yourself to your garage and it'll tell you exactly what's going on with your AC system. I have a high side gauge and I have a low side gauge, and right now they're at ambient temperature. Ambient temperature means about 50, 60 degrees in here. That means that we at least have Freon in the system, or there's air pressure in the system, but we know we have some pressure. When I turn it on, what's going to happen is the low side is going to come down. Remember, the low side is suction. It's sucking with the compressor and it's bringing it down. The high side is pressure, so it's climbing up. So it's going to climb up anywhere from 150 to 250, 300. Check your manufacturer service manual. Low side pressure is anywhere from 28 to 45, somewhere in that range. At least it's functioning properly. But a couple scenarios for you. I come over and close the high side. If I close the high side, that's going to restrict it. The high side is going to start to climb. As it starts to climb, a tip for you, the higher the high side pressure, the restriction is going to be closer to the compressor. Now, one more. Low side is high and the high side is low. The compressor is going to create a suction. So if he's not sucking it down, it's going to start to climb high. That means the compressor is not doing its job. And over here, if he's not pressurizing, this is going to be low. That means the compressor is not doing its job. So it's probably time to replace the compressor. And don't forget, when you replace that compressor, you're going to need an accumulator and an orifice tube because there's some debris in the system and you want to get rid of that. Maybe a problem with the evaporator, but you know the evaporator is located inside the car, and we're going to go there next as soon as we come back with more Tech Garage presented by Advance Auto Parts. Welcome back to Tech Garage, presented by Advance Auto Parts. Now, the case duct system, or the air distribution center for your car, is probably located up under the dash. So we went ahead and took a whole one out right here on the table so we can show you how it works. It all starts with your control head. Now, your control head's located in the car. You turn it to hot, you turn it to cold, different positions, maybe windshield, floor, whatever, blower speeds, it's all controlled right there. It can be controlled automatically. You might have automatic temperature control, but the case duct system is going to work similar. You can see right here on my case duct system, you got some vacuum actuated doors, and this is cool because I hooked it up to a vacuum pump. And if you have a vacuum actuated solenoid, I can pump this up and you can see it's actually going to open the door, allow fresh air, recirculated air, uses other case ducts to do that too. Or you may have an electric solenoid. It has a AC control module, gives it a signal, moves one of the doors electrically. Either way, we have to move the temperature doors. Now, inside my case duct system, we could take a look at a few components. Now, this is located under the car, and then there's a drain hole right here. This drips that water you see out of your car on a nice humid day because the evaporator's causing that moisture to evaporate, take it out of the air, feeling colder, and dripping it outside. Inside, up under the dash of your car, you'll have a heater core here and then an evaporator up under there. Very difficult to get to in a big job, so you want to make sure that everything's in order up under there when you do any work. The heater core is located right here, and then our blower motor. What happens with our blower motor is when you turn it on the different speeds, it can go ahead and blow the air across these. Well, you remember those laws of heat transfer. If we want heat, we may use a heater control valve, and the heater control valve allows the hot coolant to come into the heater core. When that hot coolant comes into the heater core, the heat transfers from here to the inside the car. Remember, 200 degrees, 80 degrees. It's going to transfer, you're going to get some heat. On the other hand, if we want air conditioning, we get this evaporator really, really cold, blower motor blows across it, 80 degree, jumps onto the Freon, takes a ride to the front of the car, dissipates it there. Now, here's a heater core right here that was actually leaking. You know, some people bypass the heater core so they don't have to go up under the dash to fix this, but you can see this one was leaking right here. You can pressure test the car and you can see if it's leaking, it'll drip out the AC case. You'll have to get under the dash and repair that. We're gonna talk about Freons and some leak checking. And to do that, we brought in an expert. Bobby Elks is here from AC Pro. Bobby, I know you have a phenomenal product there. Why don't you tell us a little about it?
Yeah, so what we got here, we have our best formula on the market right here. This is AC Pro, the #1 rated coldest air on the market. What it's gonna do is it's gonna help seal those rubber leaks, and it's gonna get you the coldest air possible from the vents in your car.
Now, when would one of our viewers want to use that?
Well, you gotta think to yourself how long it took for the system to start blowing warm air. So if your car started blowing warm air over a period of time, that's perfect. If they say to you, hey, you know, it was working great last summer, but not this summer, that's what we're looking for. But if it happened in a matter of hours or days, this is not gonna help them.
It's simple to use, isn't it? I mean, I used it before. I know it's real simple to use, but maybe you can demonstrate it for us.
Absolutely, it's very simple to use. We have a 24-inch braided hose on it. We have an easy connect coupler on there. What we're gonna do is we're gonna wanna connect it to the low pressure port back there. Easiest way to find the low pressure port is to follow the larger diameter line from the compressor back. It will lead you right to it.
So why don't you show them how to go ahead and hook it all up and let's see what it does.
All right, so what I'm gonna do now is I'm gonna unscrew the gauge from the top of the can. I'm gonna put this down real quick, and I'm gonna unscrew the safety tab right here. That's there so that the can doesn't pierce. Once you pierce the can, don't take the top off of it. Right. All right, then what we're gonna do is we're gonna hook this back up. We're gonna pierce this can. All right, and to get an accurate pressure reading, we need to have the car turned on. We have to have the AC set to max cool with the fan speed on its highest setting. So if you wanna fire up the car, beautiful. So right now we can see that the compressor just kicked on. That is a very good sign. That means the AC system is working. So what we'll do now is we'll reach back to the low pressure port. We'll unscrew the little cap and we'll keep it so we don't lose it. Right. The compressor is kicked off right now, so the pressure reading is gonna be a little bit higher. Now we're gonna hook this up right there. And once that compressor starts kicking back on, what we're gonna wanna do is we're gonna wanna squeeze the trigger and we're gonna add the refrigerant. And once the needle goes back up into the green zone, we're good to go.
Wow, that's easy to use. That's easy to use. All right, we can shut it off. Now, we leak checked this truck earlier, and there's a couple methods you can do to leak check a truck. Now, this is pretty simple. This is just a little electronic leak detector. You turn it on, makes a little buzzing noise when it smells or senses any Freon. But most people today, Bobby, they're using this dye. They're putting the dye in the system. Correct. You put the dye in, you got some infrared glasses, and you can see right here. If I shine it right there, you can actually see the dye. It's coming out of that little seal there. Now, I know this one's a real gradual leak. Would that product work well for this?
Yeah, any rubber seal that's leaking over a period of time, this is a great product for that customer to use.
Awesome. Well, thank you very much. You know, you may not have AC at all, or you may have that 255 AC, 2 windows at 55 miles an hour. So when we come right back with more Tech Garage presented by Advance Auto Parts, we're going to look at power windows.
This edition of Tech Garage is being brought to you by Advance Auto Parts. Let's get you back to the garage. AC Pro, do-it-yourself AC recharge for cars and trucks. Custom Auto Sound, the originator of classic car OEM fit radios since 1977. And by Steel Rubber, quality crafted rubber parts and weather stripping.
Welcome back to Tech Garage. It's time to talk about power windows and door locks. And you know, that's not an easy thing to do because they're located inside the doors, but we have this demonstrator here with the doors cut all apart so we can show you everything about it. The first one I want to look at is the radio frequency. Now, we're all familiar with these key fobs, and what this key fob does, you know all about it. You push it, lock, unlock, lock, and unlock. Well, there's a series of network communications that actually goes on. This guy's shooting a signal to a RF frequency. He's picking it up. He wants to know if it's the right signal. He may be talking to a body control module. Then from the body control module, he may talk to the instrument cluster module and say, hey, is the child locks on? Is delayed door locks on? Once he figures it out, it's okay to unlock the door. It's it's going to unlock the door. And that's all located inside the door itself. But to take a door panel off, man, that's a tricky procedure. I highly recommend you head down to Advance and get you one of these little sets right here. It has all kinds of little pullers and adapters. And why is this important? Well, we all pulled on these door panels to get in there and ended up breaking them at one time or another. This will allow you to get in there and pop it off. What we're looking for is you're actually getting up under these pins here. And when you get up under these pins, the leverage is going to pop it out. There's screws all around there. Either check your manufacturer specification of where it's located or just be careful. Pull them a little bit at a time, pull and tug, use these tools, and you'll get the door panel off. Once you get the door panel off, you have a series of hardware inside that door panel. Now what we did is we actually moved the lock solenoid out here so you can see it and you can see how it works. What happens here is when you close the door, this little mechanism here is going to lock. And then when you open it, it unlocks. That's how it locks and unlocks. Now, if it's locked and you turn your child locks on in the back here, what happens is when you pull it, it disables the mechanism. Doesn't allow it to unlock. Go there and it unlocks. Now on the other hand, if the locks are locked, the solenoid locks the lock here, then I go ahead and unlock it, nothing's going to happen because the mechanism is disabled. Then I come back, lock, unlock, lock, unlock. This is a solenoid. 12 volts one way, 12 volts the other way, lock and unlock. Now we have a power window motor right here. Simple, I run it up and run it down. You can see the regulator on the outside actually working. That's going to pull the window up and down. Quick tip for you, make sure you secure the window if you ever remove one of these because it'll drop down there and break. Now I can unplug this here. If you suspect it's not working, just come over here, put a voltmeter in. It's a bi-directional motor. Well, what does that mean? It changes polarities from positive to negative through the switch and through ground. So if I hit that, I got 12 volts positive and a negative 12 volts. Positive 12 volts and a negative 12 volts. What is that telling me? Well, I got power to the window motor. So that means I have to replace my window motor. Just use strategy-based diagnosing. If all the windows are working and this one's not, it's probably not a fuse or a circuit breaker. We looked at power door locks, windows, and air condition. There's no reason why you shouldn't be out there riding comfortably. We're about out of time for today. So from our garage to your garage, thanks for watching Tech Garage, presented by Advance Auto Parts.